All right, another example set of problems where we're looking for the x-axis intercept. Now, I chose very specifically these four equations. There's something in common that each of these four have. And what they have in common is the ratio of the y-intercept b and the slope m are the same for all of those three. What does that mean? The ratio meaning when I say b divided by m of all of these three, they're exactly the same. So let's take a look at the graph of these four lines. Again, we're specifically looking at it from the context of when these lines intersect the x-axis. Right, here are our four lines. You see that they all intersect at the point x equals 4. Now, if you take the negative of the ratio, negative b over m, you will find that all equations will equal 4. And it will make sense why that is true in when you just do a little bit of algebra. So I'll just walk through these steps again very quickly since we all know just looking at the graph that they all intersect at x equals 4. So if I set y equals 0 here, then how do I solve for x? I move this to the left, the equation, and then x is equal to the 1 over 0.25 or 1 or b over m, the negative b over m, right? So we get 4 from that. Similarly for this one might be easier to see. 0 equals x minus 4. Move negative 4 to the right side. So that's negative b is positive 4. Divide that by the slope m, we get 4 again. And similarly, we do see that also for equation 3 and equation 4. Now, in a future video, we'll talk about when lines intersect, and there's a lot of applications where we'll look at, or when we'll want to identify when lines intersect, and very unique applications when those lines intersect at the x-axis or at some y equals 0, right? So from an engineering perspective or from a financial perspective, there's a lot of real life and physical meanings that are associated with the intersect of the x-axis. And when lines intersect, that means something is common across those two models or across those two data sets. And once we get the foundation of all these linear equation problems, we can start talking about when applications show up, and it'll put a lot more meaning into why we actually want to solve for these types of problems.